For the function, f of x is x squared minus x minus 12. Fine. E, parts. Most of this should go very fast. In fact, parts A and B are Math 1200. C, D, E are this class. Part A. What's the domain? Are there any fractions, radicals, or logs? No, so what's the domain? All reals. So polynomials are the easiest because we have less to worry about. Part B, intercepts. We have two types of intercepts. We have an x-intercept. We'll start there. Traditionally, x-intercepts are harder to find than y-intercepts. How do you find x-intercepts? Set y to 0, or y is f of x. How does x squared minus x minus 12 factor? X minus 4x plus 3. What does that say about x? Good. 4 negative 3. And the other one is the y-intercept. How do you find the y-intercept? Set x equal to 0. So if we put in 0 in for x, what do we get? Negative 12. So notice we already know 3 points on our graph. We know 4, 0, negative 3, 0, and 0, negative 12. Okay, course compass may ask you to write it as ordered pairs, not leave it as x equals 4, negative 3. Okay, just as a heads up. So that's all old stuff. Part C, relative extrema and intervals of increase and decrease. What tells us about all three of those? Grandma, grandpa, the first derivative. The first derivative. Grandma and grandpa may know, but first derivative is old reliable. What is the first derivative? 2x minus 1. So now I think we're back in 13.2. I think that was 13.2. Actually 13.1 and 13.2. So remember what we do is we see where the first derivative is 0. We see where the first derivative does not exist. This is not going to contribute anything to us, so we leave that alone. So when does 2x minus 1 equal 0? Very good, when x is a half. Number line. So I need a number to the left of 1/2 and to the right of 1/2. Where are we going to put this 0 and 1? Into the first derivative. So if you put 0 into the first derivative, what do you get when you put in 1? Positive. So to the left of x equals 1/2, we are decreasing. And to the right of x equals 1/2, we are. And at x equals 1/2, we have a, careful, we're on the first derivative. Relative minimum, because the first derivative tells us about extrema, and it goes from negative to positive. So decrease then increase. So we have a relative min. And remember, 1/2 is in the domain. 1/2 comma where? Yes, so anytime you're finding the y-coordinate, you go back to the original. Anytime you make a really bad product, you go back to the original. Hence, new Coke. It was just old Coke. Like new Slurm, old Slurm. Yeah, negative 12.25. Part D. Inflection points and intervals of concavity. What tells us about inflection points and intervals of concavity? The second derivative. Well, the sequel is never as good as the original. What is the second derivative? 2. 2 is a constant, yes. The second derivative, since it's 2, is always positive. So no matter what you pick for x, Your second derivative is positive, which means your function is always concave up. So what you are experiencing right now is that thing called confusion, because it's very easy to mix up increase, decrease, relative extrema, concavity, and inflection points. So it's all about, are we talking about the first derivative or are we talking about the second derivative? So you need to do this amazing thing called labeling your work. So we don't want it to look like Linda Blair's been doing your homework where it's splattered everywhere. We want to see steps. Poltergeist. Was that Poltergeist? No, no. Don't watch it. It's a horrible movie. Part E, sketch the graph. To sketch the graph, we need this chart over here. And also, we need to combine the number lines in parts C and D. Now, I know in part D we did not draw a number line, but we can still talk about it. So our only critical number from parts C and D was 1/2. So this is just like what we did in our car example. To the left of 1/2, we decreased. To the right of 1/2, we increased. So that's part C. Part D told us we're always concave up. So concave up here, concave up here. So decreasing concave up, that's this shape. Increasing concave up, that's this shape. So our graph is going to look like these two pieces put together. So graphing it, part A does not directly affect the graph. Part B, we have an x-intercept at -3 and at +4. We have a y-intercept at -12. Oh, it's not doing it right. Well, good thing I'm not trying to show you how to graph this thing. Part C, we found we have a relative minimum at 1/2, comma, -12.25. So 1/2, comma, -12.25. Let's see where it draws this. I guess that's okay. An inch above where I meant it to be. That's okay. So we have those 4 points, the 2 x-intercepts, the 1 y-intercept, and the relative min in this case. So to the left of 1/2, we're going to draw this concave up decreasing shape. So starting at 1/2, I don't know how this is going to work now. And we're going to, oh, there's a shadow there. Is it following it? Yeah, that worked okay. So to the left of 1/2, we have the decreasing concave up shape. And to the, okay, where are you at now? I believe in you. To the right, we have the increasing concave up shape. Oh, see, you didn't even do that. That's okay. Yay! So it should look like a parabola that opens up, which it sort of almost doesn't because I blame E-beam. Bad E-beam, bad.